Alright, hey there. This video, we're going to rock out how to do parallel lines, or how to think about parallel lines, but with a little coordinate geometry or analytic geometry flair. So, a couple things we're going to talk about today. Um, and one is slope, within the context of the slope between 2 points, like you see in this diagram to your left, and the other is slope within the context of a line. So, that said, we can look at this diagram here, and some things we can think about will be later parallelograms. And so parallelograms have parallel lines, both opposite sides parallel. So my question for this uh, is AB parallel to CD? Right? Or how about BC, the other two, are they parallel? BC, is that guy parallel to AD? So I'm going to do one, and you guys are going to do the other one. Okay, so I'll take this one, right? So I'll show that they either are AB and CD parallel or not. So let's get rid of these two. So what I want to do is kind of think about slope. And of course the idea is that lines are parallel if they have the same slope, right? So lines are parallel if their slopes are the same, at least within this context, right? So if they both happen to have a slope of 11, then the two lines having those slopes of 11 will be parallel. So I need to kind of think about, well, how do I find the slope of each of these two lines? So how do I find that slope, and how do I find the slope of CD? And there's a nice little formula in the coordinate plane to give us slope, right? So slope is change of y over change of x, right? Remember that slope m, we call m slope, change of y over change of x, which one way we can write that is the difference in the y's over the difference in the x's, but that's the same thing as the difference in the other way, the y's over difference in the x's, right? Okay, so that's how we find slope between two lines. So how am I going to find out if indeed AB and CD are parallel? Well, I'm going to see if they have the same slope. Okay, so what I want to do is I want to figure out what the heck the slope of AB is and what the heck the slope of CD is. So let's find the slope of AB. So the slope of AB, well, I'm going to use these 2 points, right? A and B, right? Because AB, of course, contains those 2 points. So the y values are 6 and 2. So it's going to be 6 minus 2. That's my change in y. 6 minus 2 over, now my change in x. Right? My change in x will be, since I started with the 6 in the numerator, I have to start with the negative 2 in the denominator. Negative 2 minus a negative 3. Right? So that's the change in y's in the bottom, excuse me, the change of y's in the top, and the change of x's in the bottom, which is what slope is. Right? So now all I have to do is figure out what the heck that is. So 6 minus 2 is 4. Negative 2 minus a negative 3 is the same thing as negative 2 plus 3. And that gives me 1. Right? So here's my slope, 4. So this line AB has a slope of 4. Okay? And you can see that on the actual drawing, which it's easy enough to count, right? I'm going over 1 and up 1, 2, 3, 4. Right? Over 1 and up 4. That means it has a slope of 4. Okay. Now I need to find the slope of DC. Right? So now I have to find the slope of DC. And if that also is 4, then those lines will be parallel because they will share the same slopes. So I'm going to use the same change of y over change of x. Right? So I'm using now these 2 points to find the slope of that line, which contains those 2 points. And we can count on this one as well, but let's just use the slope. 7 minus 3, that's my change in y, 7 minus 3, over my change of x. And since I started with 7 up top, I have to start with this 2 on the bottom, 2 minus 1. Alright, so my change of y is on top, my change of x is on the bottom. Alright, so now I just have to do it out. 7 minus 3 is 4, over 2 minus 1 is also 4. Okay, oh great, so that has a slope of 4 as well. Okay, so, and of course we can verify that by counting if we wanted to, right? From D to get to C, we're going over 1 and up 1, 2, 3, 4, right? So that's a slope of 4. So hey, wait a minute, they both have slopes of 4. Great. And so since their slopes are the same, since both slopes are same, slopes are equal, then the lines are parallel. It implies AB is in fact parallel to CD. Okay. All right, so we're using slopes in a little different context, this time within coordinate geometry land. Okay, now what I want you guys to do is to prove that BC, the line, is indeed parallel to AD. Okay, so now your turn. I want you to show BC is parallel to AD. Okay, so what I want you to do right now is pause this, work it out, and then when you're finished, play the rest. Okay, show that now. Pause. Another way we can think about slopes on the coordinate plane is with lines, right? Recall we've been working a little bit with this y equals mx plus b, right? Which is called slope m, intercept b form of a line, right? So we're kind of focusing right now on slopes. And on a coordinate or Cartesian plane, two lines will be parallel if they have the same slopes, but different y-intercepts, right? So this guy has a y-intercept of 3. This line has a y-intercept of -5. But they still have the same slopes, right? 2 and 2, right? So since those slopes are the same, that means they're parallel, right? Just like here, when both these slopes in the previous problem were 4, right? Then AB and CD were parallel because their slopes were the same. So that was between 2 points. Here we have slopes of a line, right? And so if we have the equation of a line, if we can put it in a slope-intercept form, then that m, the coefficient of the x, will give us the slope of each line. And if those m's are the same slopes, and as long as we have different y-intercepts, 3 and -5, 3 and -5, then the lines will be parallel. If they have the same y-intercept, same slopes, that means they're the same line. Okay, so we're kind of making the transition from this idea, right, where we have lots of corresponding angles, there's one pair. We have lots of alternate interior angles, that's one pair, etc., to kind of thinking about lines on a plane in slope-intercept or otherwise form, and thinking about them being parallel or not. And of course they're parallel if they have the same slopes. And for these lines, different y-intercepts. Okay, so what I want you to do right now is you tell me if these lines, y equals 2x plus 3 and 4x plus 2y equals -1, are those parallel? Okay, so your turn right now is to think about these two lines and to show if they are or are not parallel. Okay, come into class tomorrow with the answer. We'll talk about it and we'll move forward. Have a great night.